The quantum mechanical model is awesome because it explains so much about what elements do. The chemical properties and some of the physical properties too of elements are largely determined by the number of valence electrons they have. And so we saw earlier that element properties vary in a periodic fashion. And that's how Mendeleev put together the first periodic table, by noticing, oh, these have these things in common, and it repeats itself. And so he ordered them by, he did mass number, now we know it's atomic number that's the correct ordering tool. But it varies in a periodic fashion. Those properties vary periodically because the number of valence electrons vary periodically. And so at the beginning of the chapter we talked about why is hydrogen so reactive and why is helium so inert? And it has to do with the number of valence electrons that they have. So atoms with 8 valence electrons, or 2 for helium, are particularly stable because they're low in energy. And all of these guys have 8 valence electrons except for helium. And so this turns out to be the most stable electron configuration. And so the elements that are near the noble gases, their electron configurations are really close. And so they're actually very reactive because when they react, they get an electron configuration that's the same as one of these noble gases. So the alkali metals, group 1A, all of their electron configurations end in S1. Let's look at sodium. Sodium has one more electron